Hey everyone and welcome back to Shulitech classes, and in today's video we are going to cover the fifth chapter of artificial intelligence, that is computer vision. So without any further ado, let's start the video. By now, we know that artificial intelligence is a technique that enables computers to mimic human intelligence. And a machine becomes intelligent when it gets training from data, right? And on the basis of what type of data we are feeding in an AI model, AI models can be broadly categorized into three domains: data science, computer vision, and natural language processing. And today we are going to discuss about CV domain of AI, a field of AI that trains computers to interpret and understand the visual world. Now, what does that mean? Well, it means that CV enables machines to see through images or visual data, process and analyze them on the basis of algorithm in order to analyze actual phenomena with images. The concept of computer vision was first introduced in 1970s. However, in recent years, due to the significant leap in technology, the world has witnessed computer vision on the priority list of many industries. Let us look at some of the applications of computer vision. And the first application of CV that we are going to discuss today is facial recognition. With the advent of smart cities and smart homes, computer vision plays a vital role in making the home smarter. Security, being the most important application, involves use of computer vision for facial recognition. It can be either guest recognition or log maintenance of visitors. It also finds application in schools for an attendance system based on facial recognition of staff and students. Next comes face filters. The modern day apps like Instagram or Snapchat have a lot of features based on the usage of computer vision. The application of face filter is one among them. Although through the camera, the machine or the algorithm is able to identify the facial dynamics of the person and applies the facial filter selected. The maximum amount of searching of data on computer search engine comes from textual data, but at the same time it has an interesting feature of getting search results through images. This uses computer vision as it comprises different features of the input image to the database of images and give us the search results while analyzing various features of the image. The retail field has been the one of the fastest growing field and at the same time is using computer vision for making the user experience more fruitful. Retailers can use computer vision technologies to track customer movements through the stores, analyze navigational routes, and detect walking patterns. Inventory management is another such application. Through security camera image analysis, a computer vision application can generate a very accurate estimate of the items available in the store. Also, it can analyze the use of shelf space to identify suboptimal configurations and suggest better item placements. Computer vision is the fundamental technology behind developing autonomous vehicles. Most leading car manufacturers in the world are reaping the benefits of investing in artificial intelligence for developing on road versions of hands free technology. This involves the process of identifying the object, getting navigational routes, and also at the same time environment monitoring. For the last decade, computer supported medical imaging application has been the trustworthy help for physicians. It doesn't only create and analyze images but also becomes an assistant and help doctors with their interpretation. The application is used to read and convert 2D scan images into interactive 3D models that enables medical professionals to gain a detailed understanding of a patient's health conditions. And one more very important application of computer vision is Google Translate app. All you need to do is to read signs in the foreign language, to point your phone's camera at the words and let the Google Translate app tell you what it means in your preferred language almost instantly. By using optical character recognition to see the image and augmented reality to overlay an accurate translation, this is a convenient tool that uses computer vision. So, these were some of the applications of computer vision domain of AI. Now, all these applications of computer vision are based on a certain number of tasks which are performed to get certain information from the images, which can be directly used for prediction or form the base of further analysis. The task used in computer vision application can depend on single image with single object or image with multiple objects. If the image is with single object, then the CV task can be classification and classification plus localization. And if the image is with multiple objects, then the CV task can be object detection or instance segmentation. Now let's try to understand them one by one. The first CV task is classification. Image classification means assigning an input image with one label from the fixed set of categories. For example, classifying the animal image as a cat or a dog or a frog. Then comes classification plus localization. This is the task which involves both processes of identifying what object is present in the image and at the same time identifying at what location that object is present in that image. It is used only for single object. For example, if you observe the image on the screen, the left image is an example of image classification model which tells that the object in the image is a car. On the other hand, the right side image is an example of image classification with localization. That tells that the object in the image is a car and also locate the presence of that object and indicate its location with the bounding box. Next come object detection model. This model locates the presence of the object with the bounding box and types or classes of the located object in an image. And at last, we have instance segmentation. Instance segmentation is a computer vision task that involves identifying and separating individual objects within an image, including detecting the boundaries of each object and assigning a unique label to each object. An instance segment algorithm takes an image as input and produces a collection of segments as output. Now that we have understood what computer vision is, its application and what type of task we can perform using computer vision algorithms, now it's time to understand how an image is made up of, how do computers store images, how do they display images on screen, and to know the answers of all such questions, we need to understand the basics of an image. First of all, let us see how an image is made up of. An image is made up of very tiny dots called the pixels. Pixel means picture elements. Every photograph in its digital form is made up of pixels. They are the smallest unit of information that make up an image. As we can see in the image, when one portion has been magnified many times, we are able to see the individual composition of the pixel, right? So now it is clear that an image is made up of round or square pixels that are typically arranged in a two-dimensional grid. The number of pixels in an image is sometimes called the resolution. As we can see in the image shown on the screen, that there are 31 pixels in width and 29 pixels in height, means there are 31 into 29 pixel in the image, means there are 899 pixels in this image. So the resolution of the image is 31 into 29 or 899 pixels. If we call the resolution of the TV is 1280 into 1024, this means that there are 1280 pixels from one side to the other and 1024 pixels from top to bottom. And in this case, our monitor could be expressed as 1280 into 1024 means 1,310,720 pixels or 1.31 megapixels. And higher the resolution of the image and better the quality of the image will be. And now let's see how the values of pixels are stored in a computer system. We know that in a computer, everything is stored in its digital form, right? So the value of pixel is also stored in its digital form, means numbers, and each of the pixels that represent an image stored inside the computer has a pixel value, which describe how bright the pixel is or what color it should be. The most common pixel format is the byte image, where the pixel number is stored as a 8-bit binary number, giving the range of the possible values from 0 to 255. Typically, 0 is taken as no color or black and 255 is taken as full color, means white. Now we need to understand why do we have a value of 255 as the maximum value. Well, since each pixel uses 1 byte of an image, which is equivalent to 8 bits of data, since each bit can have two possible values, either 0 or 1, the minimum 8-bit value that a byte can have can be obtained if all the 8 bits are 0, and then the value that comes out is 0, and the maximum 8-bit value can be obtained if all the 8 bits are 1, then the value that comes out is 255, means each pixel is a 1 byte code. 1 byte means 8 bit and the value of 1 bit can be either 0 or 1. In this way, there are total 2 raised to power 8 means 256 possibilities of values, which starts from 0 and ends at 255, which means each pixel can have a value between 0 to 255, and this value decides the color of the pixel, right? Now let's discuss a little bit about the grayscale images. Grayscale images are images which have a range of shades of gray without apparent colors. The darkest possible shade is black, which is the total absence of color or zero value of pixel, and the lightest possible shade is white, which is the total presence of color or 255 as value of pixel. Intermediate shades of gray are represented by equal brightness level of the three primary colors. A grayscale has each pixel of size 1 byte having a single plane of 2D array of pixels. The size of a grayscale image is defined as the height into width of that image. All the images that we see around us are the colored images, and these images are made up of three primary colors: red, green and blue. All the colors that are present can be made by combining different intensities of red, green and blue. In a colored image, each pixel represents a shade of a color and is made up of a combination of red, blue and green. Means each pixel contains some value of red, some value of green and some value of blue in it. Like in the given image, the yellow shade is made up of combination of three values. Value of red is 248, value of green is 186 and the value of blue is 0. Now these values are represented in their hexadecimal value, and by combining the hexadecimal value, the color gets its hexadecimal color code as F8BA00, right? In this way, all the colors have their hexadecimal color code. So this was all about CV domain of AI. And in our next video, we are going to start the NLP domain of AI. So that's all for today. Thank you so much for watching. See you in our next video. Till then, take care and bye bye.